Class, this is explain 2 of the current lesson that we are doing, trigonometric ratios of special right triangles. So in the first two lessons of this credit, we did talk about the sine, cosine, and tangent ratios. Just as a quick review, the sine of an angle is the opposite side over the hypotenuse. The cosine of an angle is the adjacent side over the hypotenuse. And the tangent of an angle is the opposite side over the adjacent. So, what we're going to be doing here is we're going to fill out this table. We want to find out the sine ratio, cosine ratio, and tangent ratio of a 45-degree angle in a 45-45-90 right triangle. So let me switch to the So let's call this the angle that we have, 45 degrees, and let's label our sides. This side is the opposite side, this side is the adjacent side, and this side is the hypotenuse. So the three formulas we have are sine of the angle is equal to opposite over hypotenuse. Cosine of the angle is equal to the adjacent over the hypotenuse. And tangent of the angle is equal to the opposite side over the adjacent side. So let me create a box. So this is my angle. And then I want to find out what sine of the angle is, cosine of the angle, and tangent of the angle. So if my angle is 45 degrees, because again that's the angle that we're looking through, the sine ratio would be the opposite side over the hypotenuse. So 1 over square root 2. And again, remember that we cannot have square root 2 as a denominator, so we have to rationalize the denominator by multiplying it by square root 2, which ends up being square root 2 divided by 2. The cosine, so is adjacent over the hypotenuse, so adjacent over hypotenuse. So we end up having 1 over square root 2, which similar to the sine becomes square root 2 over 2. And then the tangent is the opposite side over the adjacent. So we would have 1 over 1, which becomes 1. So sine of 45 degrees is square root 2 over 2. Cosine of 45 degrees is square root 2 over 2. And then tangent of 45 degrees is 1. So let's try this with a 30, 60, 90 right triangle. So with a 30, 60, 90 right triangle, we actually have two sides that we need to find, or two angles. We have a 60-degree angle, and then we have a 30-degree angle. So the triangle that's given, they tell us that the short leg is 1, the long leg is square root 3, and the hypotenuse is 2. So let me just do a quick drawing of that. Okay, so we could choose what angle we want to start with. So let's say that I choose 30 degrees to start with. So if this is the angle that I'm looking through, this is the opposite side. This is the adjacent side, and then this is the hypotenuse. So let me create a little table. So again, I have my angle, my sine of the angle, cosine of the angle, and tangent of the angle. And the first angle I'm looking at is 30 degrees. So what is the sine of 30 degrees? That is the opposite side over the hypotenuse. So 1 over 2. What is the cosine of 30 degrees? That's the adjacent side over the hypotenuse. So square root 3 over 2. And then the tangent would be the the opposite over the adjacent. So you would have 1 over the square root of 3. And if you rationalize the denominator, this becomes square root of 3 over 3. But now what if I wanted to find the 60-degree sine, cosine, and tangent? So let me just erase these labels. So now this is the angle that we're looking through, 60 degrees. And this is my opposite side, this is my adjacent side, and this is my hypotenuse. So remember, sine is opposite over hypotenuse. So that's square root of 3 over 2. Cosine is adjacent side over hypotenuse. So that's 1 over 2. And then tangent is the opposite side over the adjacent, which is square root of 3 over 1, which just becomes square root of 3. So you found all sides, all ratios, sines, cosines, and tangents, given the 3 sides. We're going to be doing a couple problems where we're going to be given one side, and knowing that one side, we're going to be able to find the other 2 sides and then create this table. So let's go back to the packet. And we're going to be on page 35. So find the unknown side lengths and trigonometric ratios for the 45, 45, 90 right triangle. So let me just draw that right triangle really quick. So you have A, B, C. The first thing they want us to do is find CA. The second thing they want us to do is find AB. And then they want us to complete the table. So let me switch back to the projector. Okay. So going back to the 45, 45, 90 rule, if the hypotenuse is 10, remember in the formula the hypotenuse is x square root 2. So you set that equal to 10. Divide both sides by square root of 2. And x is equal to 10 divided by square root of 2. Multiply the top and bottom by square root of 2. And we're left with 10 square root 2 over 2, which reduces to 5 square root 2. So that tells us this is 5 square root 2, and this is 5 square root 2. So now I have all my sides. CA is 5 square root 2. AB is 5 square root 2. Now, if you want to complete the table, so you have the angle, the sine, the cosine, and then the tangent. And the angle that they give us is 45 degrees. So let's say that this is the angle that we're looking through. This would be my opposite side. This is my adjacent side, and this is my hypotenuse. So the sine would be 5 square root 2 over 10, opposite over hypotenuse. The cosine would be 5 square root 2 over 10. And the tangent would be the opposite over the adjacent. So 5 square root 2 over 5 square root 2. Now, actually, these could all reduce. 5 square root 2 over 10 reduces to square root 2 over 2. Same thing here. This becomes square root 2 over 2. And this becomes 1. So for your homework, you have some problems where you have to use the 45, 45, 90, the 30, 60, 90 right triangle special theorems. And then you have some problems I guess they're not asking you to find or create tables. Actually, right here. On the 13.3 checkpoint, you need to use trigonometric ratios to find the unknown side lengths of each triangle. So this is where you're going to be using the ratios. All right, and that's this lesson, 13.3. And then once you're done with this, if you guys can take a picture of your homework and send it to me through email, I could grade it and give you a grade for that. Thank you.